All right, this is 6th grade Unit 2, Lesson 13. And in this lesson, students are going to continue taking their understanding of that double number line to represent equivalent ratios. And they're going to connect that to a table of equivalent ratios because sometimes you want to know one versus the other, and sometimes it's easier to glean information from one version than the other. So let's get started. All right, we're going to start with the classic number talk. In this case, all the division we want to be done mentally. And you'll notice we're always starting with 150. First we divide by 2, then we divide by 4, then we divide by 8. So we're doubling what we're dividing by each time. And we're supposed to locate those values on the number line down here. So what's 150 divided by 2? So we know that you cut it in half, you get 75. That's pretty straightforward. Now, if you're going to divide by 4, that means you're going to take that 75 and you're going to divide by 2 again. And that gives us right here, which is, what is it, 37 and a half? Yeah, 37 and a half, because half of 75 is 37 and a half. And I notice that I put one over here, because when we're dividing by 4, we're taking the 150. And we're cutting it up into 4 equal pieces, and we want to know the value of one of those pieces. Now, if we're going to divide by 8, what is that going to look like? Well, it's going to go right here, and it's going to be whatever the heck 37 and a half divided by 2 is. Oh my goodness. So I'm going to leave that up to you to be thinking about how would you cut 37 and a half in half. So we have that table. That big old classic table here. Let's get these a little bit larger. And then it says, the other day we saw that Han can run 100 meters in 20 seconds. Han wonders how long it would take him to run 3,000 meters at this rate. So you can start to see 100 meters in 20 seconds right here. 100 meters, 20 seconds. And then he wonders how long it would take him to run 3,000 meters at this rate. Now, do you agree with this table, how this table represents the situation? Well, I see 120 up here. I see 3,000 down here. I'm pretty happy, right? Then why are they asking us if we agree with the table? So we're going to skip all the way to question 4. What could Han do to improve this table? Well, parents and teachers, we want to label things. So we want to get students to start to label. So when we have this ratio of 100 meters in 20 seconds, and then we see this value right here, we see that 100 meters, this 100 represents meters and this 20 represents seconds. So we're going to label that M for meters and S for seconds. So when it says, do you agree with this table, this 3,000 is supposed to represent meters, isn't it? So that 3,000 really needs to be over here as our 3,000, which means we want to erase that 3,000 from the seconds column because it's supposed to be 3,000 meters, not 3,000 seconds. So complete the last row with the missing values. So you notice I had to switch it because I didn't want that 3,000 where it was. I needed the 3,000 to be on the meters side. And then let's continue. So if I want to know how many seconds it would take to run 3,000 meters, well, I can see that 100, let's do it in green. I can see that 100 times 30 gives me 3,000. So what am I going to do with that 20? I'm going to multiply by 30. And that's going to give me 600 seconds to run 3,000 meters. So what question about the situation does this number answer? Now, because I switched it, I now know that it's 600 seconds to run 3,000 meters. Now, prior to me switching it, when the 3,000 was on the seconds side, if I didn't change anything and I just left the 3,000, I would be finding what value how many meters would Han run in 3,000 seconds? But because I switched it, I'm answering this original question. So how could he improve it? Really by including labels so that we don't put our values in the wrong columns. So more of the same here. Priya can bike 150 meters in 20 seconds. So let's fill that in. So we've got meters in seconds, and our big value, our original rate that we have been given is we're told 150 meters in 20 seconds. And then it says at this rate, how long would it take her to ride 3,000 meters? So there's our 3,000. So somehow we have to come up with like a recipe for figuring out how we're going to turn 150 meters into 3,000 meters. And that's not actually terribly hard on this one. We're going to multiply by 2. That gives us 300. Then we can multiply by 10, and that gives us our 3,000. So we're going to follow that same process. 20 times 2 gives us 40 seconds, times by 10, that gives us 400 seconds. So we can see that in order for Priya to bike 3,000 meters, it would take 400 seconds. Now over here, Priya's neighbor has a dirt bike that could go 360 meters in 15 seconds. At this rate, how long would it take him to go 3,000 meters? So we have to make a new table, don't we? We need to make a new equivalent ratios table. Let's stick with meters on the left, seconds on the right. And our initial value or rate is 360 meters in 15 seconds. And again, we want to figure out how long is it going to take for Priya's neighbor to go 3,000 meters. So somehow we have to turn 360 into 3,000. And there's a variety of ways we can do this. I'm going to think about, let's divide by, 3. So if we divide by 3, so that's the same thing as multiplying by a third, I get 120. And then if I divide by, let's divide by 4. So I'm going to multiply by a fourth. When I do that, I get 30. Because then I can multiply by a 10. Multiply by 100, and that gives me 3,000. Now, is that the only way we can turn 360 into 3,000? Nah, there's other ways to do it. In fact, there's an infinite number of ways that we can do it. But that's just one way. So let's follow that same recipe over here. We're going to begin by dividing by 3, which is the same thing as multiplying by a third. That gives us 5 seconds. Then we're going to divide by 4, which is the same thing as multiplying by a fourth, which gives us 5/4 of a second. And then we can multiply by 100. That gives us 500/4. And I would need to do a little bit of division to figure out exactly how many seconds 500/4 is. And if you're not sure how many seconds that is, all we have to do is do 500 divided by 4, and that'll give us the number of seconds. So this is a wonderful activity, parents and teachers. So the idea is you've got this information about the space station, and you're going to get your kids into pairs, teams of 2. One person, you're going to give that person a table. The other person, you're going to give a double number line, and the students are going to work collaboratively to fill in all the information that they can using both of these pieces of information. And as we're doing it, students are going to be discussing, hey, what do you see happening in both instances? What do you see in a table but you don't see in a double number line, and vice versa? What do you see in both of these things? It's just a really great way for students to engage in academic discourse discussing the similarities and the differences between a table and a double number line. And just to wrap up, the idea is double number lines look like this. Sometimes those double number lines are nice, but sometimes they get a little bulky, gets a little complicated, so you want to convert that double number line experience into a table. And because sometimes one representation is easier than the other. All right, so let's do a little bit of practice. So our first problem, it says we have a double number line that shows the connection or the relationship between powder and water. And here's our relationship. It says we're supposed to make a table of that same information. So let's do it. Let's do powder right here, and then water right here, and boom, 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 boom. And so we can see right here, 0 and 0. Right here, we've got 1.5 and 2. Right here, we've got 3 and 4. And right here, we've got 4.5 and 6. More of the same. It says a bread recipe uses 3 tablespoons of olive oil for every 2 cloves of crushed garlic. Complete the table, draw a double number line, and which representation do you like the best? So let's do it. All right, so here is our table. And so our table, and there's our initial rate, 3 tablespoons of olive oil for 2 garlic cloves of crushed garlic. So if we are going to times by a third, meaning divide by 3, means we're going to times by a third over here, which means we're going to get 2/3. And then if we're going to double it, times by 2, that means we're going to double it, which means we're going to have 4/3. We could simplify that, but let's just leave it. And then here, how do you go from 2 to 5? Do we have to go from 2 to 5? No. We could go from 1 to 5. Ooh. So we could times by 5. That's how we get 5. So we could take our 2/3 and times by 5, and that's going to give us 10/3. And then all we have to do is double. To go from 5 to 10, we double. Which means to go from 10/3 to the next answer, we double it. And we get 20/3. Now, parents and teachers, in each of these cases, if we want to simplify these fractions, we can, but we don't have to. All right, now it says we are supposed to take that and relate it to a double number line. So here's our double number line. And let's do, it doesn't matter which is which. Let's do olive oil down here, and let's do crushed garlic right here. And we know that at the beginning, it's 0 and 0. So taking this first ratio, 2 and 3, so 1, 2, and there's our 3. 3 olive oils is equal to 2 garlic cloves. And then if we want, oh my goodness, if we want 1 olive oil, that means I'm going to erase this, put it back in there, and I need 1 olive oil, which means this is going to be 2/3 crushed garlic. Then if I want 2 olive oils, that's right here, that means that's going to be 4/3 right here, 4/3 crushed garlic. And then if I want 5 olive oils, okay, 5 olive oils. Where's 5 olive oils? Well, there's 4, there's 5. So 5 olive oils straight above is 10/3. And then lastly, this last one, 10. So 6, 7, 8, 9, 10. Here's my 10. And I know that that's going to be 20/3. Oh my goodness. So when you look at this, I don't know about you, but for me, I find navigating through the table a little bit easier than navigating through the double number line. But parents and teachers, if your students have a preference one way or the other, let them go with it. Although we do want students to know both representations and how to flow back and forth between the two. All right, so we have Claire. She's traveling at a constant speed. There's our double number line. At this rate, how far does she travel in each of these intervals of time? So down here, we want to talk about these values. So I'm going to take this and I'm going to turn it into a table. Why? Because I like tables. And I'm going to put my hours on the left and my miles on the right. Why? Because I want to. I could have chosen the opposite, and I'll still end up with the correct answer. So we're going to put that 0 and 0 because that's what that says. Then 2 hours is 72 miles. 4 hours is 144. 6 hours is 216. So there's our table of equivalent ratios. And then it says, at this rate, how far could she travel in 1 hour? So there's our 1. So how are we going to get 1? Well, I see an easy way, not the easy way, but a easy way, is to take that 2, multiply by a half, which is the same thing as divide by 2. And that's how I get 1. So I'm going to do the same thing here, divide by 2 or multiply by a half. And that gives me 36. And then 3 hours. What am I going to do? Well, I'm going to put 3 right here. And I can see a nice, quick, easy relationship. I could take that 1 and triple it, times by 3. That gives me 3. So I'm going to take my 36 and triple it. And that gives me 108. Right there. And then the last one, 6.5 hours. Oh my goodness. So what am I going to do with that 6.5 hours? Well, I think what I'm going to do, I know I want 6.5 hours, right? So I think what I'm going to do is I'm going to take that 1 and I'm going to multiply it by 6.5. That gives me 6.5. So what am I going to do with my 36? I'm going to multiply it by 6.5. So I'm going to take my calculator or multiply by hand and take my 36, multiply by 6.5, and that is going to give me this answer right here. So we're going to go to a little bit of review here. And it says Lynn and Diego travel in cars on a highway at constant speeds. In each case, decide who was traveling faster. So during the first half hour, Lynn travels 23 miles while Diego travels 25 miles. So who is traveling faster? Well, Diego, because in a half hour, Diego traveled faster than Lynn. I mean, he traveled further than Lynn, so that means he was traveling faster, or traveling faster than her because he traveled further. Whoa, further is faster. Wow, my goodness. And then after stopping for lunch, they travel at different speeds to travel the next 60 miles. It takes Lynn 65 minutes to travel 60 miles. It takes Diego 70 minutes to travel 60 miles. So who is traveling faster? Well, in this case, it was Lynn. Why? Because she traveled the distance in shorter time than Diego, so she was traveling faster. Whereas here, Diego traveled further, which means he was faster. Oh my goodness. So this is where we're really starting to see that relationship between distance and time and how those things can be used to decide who is going faster. Another little bit of review. A sports drink recipe calls for 5/3 tablespoons of powder for 12 ounces of water. How many batches can you make with 5 tablespoons of drink mix? All right, so we are going to we can either make a equivalence table, or we could do a double number line. So let's do a double number line because they're kind of telling us that's a review question. So let's do that. And so let's do our powder down here and our water up here. And we know that if we begin with them both at 0, it always begins with 0, right? And so we know that 5/3 5/3, there we go, is 12 ounces of water. So if we add another 5/3, so that's 10/3, we're going to add another 12 ounces. And then we're going to add another 5/3, so that's 15/3. By the way, that's 5, which means we now have 36 ounces of water. And then if we have another 5/3, so that's 20/3, we're going to have another 12 ounces of water. And then another 5/3, and then another 5/3. Wait, let's see, 5 times 3 is 15. Oh, look at that. Hey, we're done. Look at that, 5 teaspoons. So there is our 5 teaspoons. It's right here. Look at that. I don't know what I was thinking. So there's our 5 teaspoons. So look at that. So 0 batches. And then we have 1 batch, 2 batches. Here are our 3 batches, which is our 5 tablespoons of powder. So it turns out we can make 3 batches. Ooh, a blast from the past. We're reviewing surface area and volume. So it says, what is the surface area of the cube? So now you got to remember that surface area is these colored faces. So we can see, and I love the fact that they give us color, that this is 9, this is 9, this is 9. So the surface area is going to be 6 faces times 9 is 54 square units, because there's 6 faces, 6 times 9. Then it says, what is the volume? So now we're talking about cubes, all the individual cubes right here. There is an individual cube right there. And we could see that in the top. Oh, let's get an eraser here, and let's erase that. And we could see that in this top layer right here, there's 9. Then there's 9 in this layer and 9 in this layer. So in each layer, there's 9 cubes. So 3 layers times 9 gives us 27 cubes. And that wraps up 6th grade, Unit 2, Lesson 13. Students are continuing to connect their understanding of the double number line with tables.